Hello students, I welcome you all in the discussion of physics paper of Re-NEET 2026. We are going to discuss code 50 of physics paper. So let's start. Let's start with the question number 1. Question number 1 is saying a particle of mass m is moving on x-axis on a surface, coefficient of friction of which is variable. We have to find the work done of frictional force. So what we can say कि work done W is equals to integration of F friction into dx. We know that F friction we can write as mu naught minus alpha x, which is mu, mg is the normal force, into dx, and we have to integrate it from 0 to L. So after doing this, we are going to get m into g, and in bracket you will get mu naught x minus alpha into x square divided by 2. So that is what we are getting as a work done. Now they have given one more information that mu is going to be 0 at x equals to L. So from there we can get the value of alpha. So we can say mu naught minus alpha into L, that is going to be 0. So we can get alpha is equals to mu naught divided by L. So as you're going to put here, and after putting the limit from 0 to L, what we are going to get is mu naught mg into L by 2. Now if you compare with this one, what is the value of n? So we will get n as 1 by 2, which is matching with the question, which is matching with the option 4. Now let's move to the question number 2. Question number 2 is basically, it's a question of mean free path. We know the formula of mean free path, lambda is equals to 1 by root 2 pi n d square. That is the formula. Now what they are saying that it is for, means mean free path of A is half of that of B. So we can write 1 by 2 root 2 pi n A whole square, where it is molecule density. They are saying diameter of A is twice. So let's say it's 2d whole square, and that is 1 by 2 times of 1 by root 2 pi nb whole square and d whole square. After solving this, we are going to get na by nb as 1 by 2. So it's na is equals to, it is nb divided by 2, which is matching with option 4. So for question number 2, answer is fourth one. Now if we talk about the question number 3, we have to find the ratio of potential difference between point AB, which is here in this first part P, and this is in second part. Alright, we have to, this they are saying it is EP, and this they are saying it's EQ. It's very simple. Solenoids are identical, so we can say EP as 1 by, it is L is the inductance of this, it's L into di by dt. And if you talk about this one, we know that effective inductance of this becomes L by 2, so we can say EQ as L by 2 into di by dt. Now if you take the ratio of this, we are going to get answer EP by EQ as 2, which is again matching with option 4. So for the question number 3, answer is fourth one. Now let's move to the question number 4. They are saying the for sound wave, if the number of notes for the fifth harmonic in an open end organ pipe. So for open end, we know that for first harmonic it is first one node. So like this we can say for nth harmonic, for fifth harmonic it is fifth one. So we can say number of nodes in the fifth harmonic will be 5. But whenever we are talking about a closed organ pipe, in first harmonic it is one node, in second harmonic if you talk, third harmonic if you talk, it is going to be like this. So you are going to get 2 nodes. Alright, so if you're going to talk about which type of harmonic we are going to get when the one end is closed, so it is first one you will get, then you will get third one, then you will get fifth one, then you will get seventh one, and then you will get what? Ninth one. So in ninth or in this you will get one node, in this you will get two node, in this you will get three node, in this you will get four node, and this you are going to get 5 node. So for this m is equals to 5. Now if you talk about the ratio of m by n, so n by m is equals to how much? 5 by 5, so it's 1. So it is matching with the option 3, which is 1. Now let's move to the question number 5th one. They are saying consider a long solenoid for which length is r and radius is r and turn density they have given as n. So n is given as a turn density. They want to find the inductance. Again, it's very simple question. We know that mu naught n square is the inductance per unit volume, and for the solenoid we know that volume will come out as pi r square, and r is the radius and length is l, so pi r square l, that will be the inductance. So it is matching with the question with the option first one, mu naught pi n square r square l. So for the question number 5, answer is 1. Now let's move to the question number 6. They have given the displacement of a particle which is moving in a straight path, and they have given the value of alpha, beta and gamma. So let's write in terms along with the constant here. So we can say s is equals to how much? T square, as alpha is 1, minus 6t, and gamma is how much? 5. Is that clear? So it's a quadratic equation. If you differentiate it, you're going to get the velocity. What is that? It is 2t minus 6. They want to find the average speed of the particle. So we have to find the distance traveled by particle during 6 seconds. Acha, one more thing, if you find the initial velocity of this, then v initial we are going to get as a what? 6. And whenever you're going to calculate the acceleration of this, then it's minus 6 we can say, and a is going to be how much? 2 here. If you differentiate again, you can get acceleration as a 2. So basically what I'm saying, if the velocity is this side, initial velocity, and acceleration is constant, which is 2 here. So this particle is going to take U-turn. Again, it is given that after what time it will take the U-turn. So basically particle is going to take the U-turn after 3 seconds. After next 3 seconds, it will be at same position. So if you put t is equals to 6, you will get the displacement as 0, means particle is again at the what? Same position. So what we can do here, we can find the stopping distance. So a stopping distance, we can say that a stopping distance will be u square by 2a. That will be 6 ka whole square divided by 2 into 2. That is the stopping distance. Distance traveled by the particle is double of the stopping distance. So we can say 6 square divided by 2 into 2 and double of this. Now we have to find the average speed. So we divide with the time. So divide with the time, which is going to be 6. If you solve this, this and this will get cancelled. It will be 6 by 2. So the answer is 3. So it is matching with the option 3. So for the question number 6, answer is option 3. Now let's move to the question number 7th one. In this question, they want to find the Q value. Which value? Q value. So we know that if you are going to, here mass of product and reactant is given. So whenever you are going to calculate, if you see this data, whenever you are going to calculate the mass defect, if you see here, this is 238 and 234 plus 4 is 238. So there is no difference in that. Whatever the difference we are going to get in these values, right? So if you add this together, it is 0.446, but what is this? 0.050. So if you find the mass defects, delta M is going to be how much? 0.004 U, right? So what we can say that delta Q is equals to how much? Delta M into C square, right? So we know that 1 U into C square is 931.5 mega electron volt. They have already given, right? So whenever you're going to put this value mass here, you are going to get as 3726 kilo electron volt, because they are asking the answer in the terms of what? kilo electron volt. So it's very simple question. You have to do delta M into C square. So for the question number 7, answer 1. Option 1 is correct. Alright. Now, again this is the question based on photoelectric effect. They are saying that a light is incident such that the power of this is decreasing linearly. So basically we can say that power is proportional to number of photon incident per unit time. So if the number of power is decreasing, here we can take the frequency as constant and we can decrease the n linearly. So when n is decreasing linearly, we know that current is proportional to number of photon. So current is also going to decrease linearly. But since frequency is not being changed, in photoelectric effect, the generally intensity of power is related with the number of photons. So here we will take the frequency as constant. So as stopping potential, we know that EVS is equals to h mu minus 5. So a stopping potential is not going to change as frequency is not changing. So a stopping potential will remain constant with time. So what we have to find here, what we got here, that current is decreasing linearly but a stopping potential will remain constant. So according to that, the most appropriate answer for the question number 8 is option 1. Now let's move to the question number 9. Again, it's very simple question based on the capacitor potential energy, right? So we know that we have to find the ratio of UP divided by UT. UT they have given that it is the total power stored in the system. We know that if this voltage is V, it is identical capacitor. So this will be V by 2 is the potential difference across this. And for this, so first of all, we know this is C, this is C, this is C. So let's calculate the UT first. This is C and C in series, so C by 2 and parallel with the C, so that is 3C by 2. So total energy stored is 1 by 2, 3C by 2 into total potential V square. So what we can get from here? We are going to get 3 by 4 CV square. That is the total energy stored. If you want to find the UP means the potential difference across this is how much? V by 2. So we can say it is 1 by 2 of C of V by 2. So this is going to be how much? Ka whole square. So this is going to be CV square divided by 8. Now they want you to take the ratio of UP by UT. So if you take the ratio UP by UT, you are going to get as 1 by 6. So it is matching with the option number, with the option 4 here. So for the question number 9, answer 4th one is correct. Let's talk about the question number 10th here. In this question, it is based on the Bernoulli theorem, and here they want you to find the rate of volume flow. So one more information is given. They have taken the 2 point P and Q here, for which they have given the difference of the power, and area of cross section is also given here, right? So seeing the area of cross section, you can see that ratio of area cross section is 2:1. So here we can say the velocity is V, then here velocity will be 2V, right? And height is same. So what we can say? We can say P1 plus 1 by 2 rho into V square is equals to P2 plus 1 by 2 into rho into 2V whole square. 2V whole square. So from here what we can get? They have given the P1 minus P2. P1 minus P2 will be equals to 1 by 2 rho into 3V whole square. This they have given us 15. So 15 into 1 by 2, and this is how much? 1000 for the water, as they have seen. Alright, for the water you know that it's 1000, and it is 3 into V whole square, right? Now if you bring it here, this is 5. Alright, and as you solve this here, you will get V as 1 by 10. V as 1 by 10. So we got the V as a 1 by 10. Now volume flow rate we can say A into V. A they have already given at P this 40 centimeter whole square, and speed is how much? It is 1 by 10 meter. 1 by 10 meter per second. So we can say it is 10 centimeter per second. Now put here 10 centimeter per second. In centimeter cube per second, you are going to get it is 400. So it is matching with the option 4th one. The answer is 400, right? Option 4th one. So for the question number 10, answer 4 is correct. Now they are saying a current of I naught is flowing. They want, in this question, they want you to find the magnetic field at center. But the for each semi part the resistance is different. They are saying the resistance of ABC is half of ADC. So for the ADC, let's suppose it's 2R, then for this is R. Now this current is also going to divide in inverse of their resistance ratio. So in this, how much current will flow? I naught by 3. And this, how much current will flow? 2 I naught by 3. Now if you talk about this, one is clockwise, another is anti-clockwise. So the magnetic field produced by them is in opposite direction. Due to this one, it is inward, and this one, it is outward. So basically we know that due to semicircle, it is mu naught by 4R times of current. We know that here they are opposing in nature, so we will take the difference of current directly. So that is 2 I naught by 3 minus I naught by 3. What will this become? The B at center will become mu naught I naught divided by its 12R. So again it is matching with option 1. So for question number 11, answer 1 is correct. Now let's move to the question number 12. They want you to find the relation between the terminal velocity and the ratio of rho by rho, where rho is the mass of the spherical ball they have given. So if you want to write the formula for terminal velocity, we know that terminal velocity is 2 by 9 zeta r square rho minus rho into g. Now first of all we have to find this ratio. It is given as rho by rho. So let's divide with this. So we can say Vt is going to be, this is constant, this is not changing. So this whole thing again we can take constant. So we can say it is something constant time of rho sigma by rho minus 1. Alright, now this we can say y, this we can say some m into x minus c type, right? So we know that for this it is the equation of a straight line. Slope is positive but intercept is negative. It is matching with which one? The option 1. Here we can say the slope is going to be negative, and if you put, when this value becomes equals to 1, then again it is going to be 0. So according to this equation, it is a straight line and it is matching with the option 1. So for question number 12, answer 1 is correct. Now let's move to the question number 13. They want you to find the ratio of escape velocity if they have given you the information about the radius and mass of the planets. So we know that escape velocity for any planet surface is root 2gr, right? So you can also write as root gm by r square into r. So its v escape is proportional of root of gm by r. We can say it's proportional to this. So we can say कि v2 by v1 is nothing but it is root of m2 by r2 into how much? Root of r1 by root of m2. M1 here. Mass is given same. So this and this will get cancelled. So v2 by v1 is going to be root of r1 by r2. They have already given the ratio of the resistance, right? What they have given? r1 by r2. r1 by r2 they have given as a what? 2. So root of this will be root of 2. So it is matching with option 3. So for question number 13, answer 3 is correct. Now question number 40, they are saying that for a solar system, time period of revolution of planet with radius, how it is varying. So we know that time period is proportional to r to the power 3 by 2, Kepler's law of time period. So it is matching with the option 2 here. So for question number 14, option 2 is correct. Now if you talk about the question number 15, they have given the information here that is 2 wire, both are carrying the current in the same direction. A has current I and B has current 2I. Again they are saying that B is kept fixed at some height. So this is B, it is kept fixed at some height. while A is lying on the horizontal surface. Now they are saying what is the minimum value of H so that it is not going to get lifted. So we have to balance the force here. This wire will try to attract this wire and it will be balanced by the gravitational force. Mass per unit length of the A is already given. So we know that force per unit length due to magnetic field is mu naught I1 I2. So I square 2 by separation is H. So 2 pi H, that is the force between the two wires, and that should balance, means magnetic force is going to balance the gravitational force per unit length, right? So this will be equals to how much? Lambda z. Now 2 and 2 will get cancelled. In this we want to find the H. So H will be equals to mu naught I whole square divided by pi lambda g. So it is matching with option 2. So for question number 15, option 2 is correct.
So let's start with the question number 16. In this, an ideal Zener diode is given to you with a breakdown voltage of 3 volt and it is connected with a supply of 5 volt. As you can see that this is a reverse bias and this has 3 volt as the potential because this is connected in reverse bias and the applied voltage is greater than its breakdown voltage. So it will keep 3 voltage as the voltage across its terminal. So the remaining voltage will be supplied to the resistance. That's why the answer will be 2. Now the next question is, in an adiabatic expansion, the temperature of 1 mole, that means value of N is 1, which is given to you, of an ideal monoatomic gas. So this is monoatomic gas and gamma is already given to you, that gamma is 5 by 3. It decreases from 60 to 50. The work done by the gas will be, so work done by the gas will be NR delta T divided by 1 minus of gamma, right? This will be 1 minus of gamma. When you write this, I just want the magnitude part. I don't need the like what will be the sign of this. I don't need to bother myself for that part. So N will be 1, R is 8.3, right, times delta T. Delta T will be 10, right? I'm taking only mode part, right? 1 minus of 5 by 3, right? So when I'll solve this, it will be 8.3 times 10 divided by minus 2 by 3. Again, I'll not take that sign, right? After solving this, this will be 8.3 times 3 divided by 2 times 10, right? So the value will be 124.5. Next, a ray of light with wavelength lambda is incident on 3 different photoelectric cells. So we have 3 different photoelectric cells. Let's suppose these are the 3 cells, and it has lambda 1, lambda 2, and lambda 3 as the threshold wavelength, correct? Threshold wavelength respectively. The magnitude of stopping potential is given to you as V1, V2, V3. So you need to consider V1, V2 for this and V3 for this, correct? The relation between lambda and the threshold wavelength is given to you. These are the 3 relations which is given to you. And in this case, lambda is the light which is incident. So over here also this is lambda, over here also this is lambda, and over here also this is lambda. So all are lambda. You have lambda 1 as the threshold for the first plate. For plate 2, this is lambda 2. For the third plate, it is lambda 3. Correct. So the energy corresponding to this part, we need to verify this part first. So lambda 1 is lesser than lambda. This is given to you. Lambda 1 is lesser than lambda. So in this case, lambda 1 is already less than the incident wavelength, right? So when this is less than, you know that E is equals to hc by lambda, right? Lower is the wavelength, higher will be the energy, right? So if wavelength is higher, energy will be less. So in this case, the energy which is incident or energy of the photon will not be sufficient to pull out any of the electron, to knock out any of the electron from the first cell. So this will be V1 is equals to 0. Similarly, when you compare this, lambda 2 is greater than lambda, right? In this case, lambda 2 is greater, so higher energy, right? lambda 2 is greater, that means higher energy of lambda as compared to lambda 2. And in this case, lambda 3 is much greater than lambda. That means the energy required for the third plate is very less as compared to the energy incident on the third plate. That's why V2 will be lesser than V3. Next, a photon and electron of energy. This energy is given to you, right? And in this case, energy of momentum of the photon. So basically, linear momentum of the electron to that of linear momentum of the photon, right? So you need to just take the ratio of these two. So when you write the linear momentum of the electron, that will be under root of 2 me into k. K is the energy, right? Or you can just write, instead of k, you can write it as under root 2 me e, the energy. If it is kinetic energy, use that kinetic energy. If normal energy is given to you, so you'll use that energy over here. P of photon, that will be h by lambda, and you can write that as E by C also, because E is equals to hc by lambda. So in this case, you'll just write that, okay, this is 20, right, by 3 into 10 to the power 8. Just keep this in mind that when you use the values given to you in kg, remember to use the energy in joules, right? Because if you are using everything in the standard units, you need to use the energy also in the standard unit. And the energy is joules as the standard unit, right? So this will be 20 times 1.6 into 10 to the power minus 19. When you solve it, you'll get third as the answer. Next, which of the following measurements require index correction? So index correction, this is directly from the experiment, right, of finding out the focal length. So the answer of this will be third, right? Now next, a unit positive charge. The value of Q is 1, which you are taking from this point to this point, correct? And what you need to do, this is a dielectric. There's a gap over here, or you could say that there's a road kind of gap, right? So this charge starts from this point and it ends at this point, passing through this gap, right? So there's a tube-like gap in the, there's a tube-like gap, right? There's a tube-like gap between this sphere. Now this sphere is a charged dielectric sphere of radius r. So you will consider this as solid, non-conducting. So whenever the part dielectric is given to you, it is for non-conducting, and this is solid, this is given to you, right? Now you need to find out the work done if you move it from this point to this point. So simple question, you don't need to worry about that what will be the potential at this point or how will we solve it. We just need to write down the potential at this point. That means VA. So VA will be K, Q, this will be K capital Q, K capital Q by 2R, the distance. Then VB will be equals to K, Q by 3R. Now the value of Q. Q is the charge on this sphere. How you will write that? See, charge density is given to you. So you'll write Q as rho times of 4 by 3 pi R cube. So when you use this in this formula, you take the difference of VA minus VB, right? This is the difference you need to take, mode of it you can take, because you just need to write down the magnitude of that part, right? So VA minus VB, just take that, and that will be equals to 1 into the work done. 1 over here, one into the work done, because work done is what? Work done is Q times delta V, The change in potential times the charge is equals to the work done. So we use that part and we can write down the value. If you write down that value, you'll be getting 18 as the value of N. Next. Now this is quite interesting question. You just need to find out the difference of H1 and H2. Correct. This is the apparent depth. So the situation is you have a liquid over here which is of the thickness 5 centimeters. This is of the thickness of 5 centimeters. 5 centimeters. And this is placed exactly in the middle of this layer. This is 2.5 from this side and 2.5 from this side. Correct. And the respective refractive indices are also given to you. H1 is the value of the apparent depth if you look it from medium P. This is medium P. So if the observer is in this medium, in that case, he will see H1 as the apparent depth. So if we write that, this is the formula for apparent depth. Apparent depth is equals to mu r by mu I times HR. This is real depth. This is apparent. This is the refractive index in which refracted rays are present. Mu I is the refractive index of the medium in which incident rays are present. So this is the object. Incident rays will travel like this. From this point, it will travel like this. Correct. So this is incident medium, this is refracted medium. So if we write the value of H1, that will be mu r. Mu r is 1 divided by 1.25 times the value of this real height or real depth. So this will be 2.5 and this is 2 centimeters. Similarly, if I write the value of H2, that will be, so observer will be over here. Correct. Incident ray is this, reflected ray will be in this medium. So this will be 1.5 mu r divided by mu I, which is 1.25 times the value of this, which is 2.5. So this will be 3 centimeter. Difference of these two will be 1. Now, this question, you have a frictionless circular wire. So that means there is no friction over this wire, right? So the wire is like this. And two particles are there which starts from this point. Correct. They start from this point and they move like this. With 2 point particles of unit mass start moving simultaneously. Time is also same. With identical uniform angular speed. See, the information given to us, identical, that means both are moving with the same angular speed, right? And this is uniform, that means it won't change if they move from this point to any other point, right? So omega is same for both the particles and it is constant also. That means you can say that speed with which they will be moving along this circular path will be same. So if they start moving like this, at this point, as you can see that momentum will cancel out. Now there's a very interesting part over here, which is the magnitude of the total linear momentum. Magnitude of total linear momentum, right? That means you need to write down P1 vector plus P2 vector mode, right? You don't need to write down P1 mode plus P2 mode, no. You need to write down P1 vector plus P2 vector mode, right? So for this part, this will cancel out. So there won't be any momentum over here. And if you take this point, at this point, this will be the value of V, because this particle will be moving this way and this particle will be moving this way. Again, they'll cancel out the momentum. That means at this point and at this point, the value of momentum will be 0, right? Then we need to check in between. So let's suppose we have this point. So at this point, speed will be like this, tangential. So I'll have two components, one is this, the other one is this. Similarly for this particle, because they are starting from the same point at the same time with the same speed, so can I say they will be at the same line? This will be V, so there will be a component which is Vx, there will be a component which is Vy, and this will also be Vy, and this will also be Vx. This Vx will cancel out. Only component which will be added will be Vy, correct? So when they reaches this point, the complete velocity will be in the y direction, correct? So this will be the maximum momentum at this point. And according to that, third will be the correct answer, because at minus pi by 2 and pi by 2 both, the value of total momentum is 0. And at a midpoint of their journey, this is the complete journey, and at the midpoint of this, the momentum is maximum. That's why this is the answer. Next, the temperature of a metallic sphere of radius r is increased by small amount delta T. So temperature we are increasing. There is a sphere, metallic sphere of radius r, and we are increasing the temperature. The coefficient of linear expansion is alpha. The approximate increase in the volume. So you know that delta V will be equals to gamma times of V naught times delta T. V naught is the value of volume at the initial temperature, and gamma will be equals to 3 times of alpha, correct, if nothing is given to us. So this will be 3 alpha, and this is 4 by 3 pi, and this will be r cube times delta T. So you'll be getting 4 pi r cube alpha into delta T. Third will be the answer. Next, a cylindrical cork of uniform density floats in a liquid of density ρ1. So the situation is that you have a container. There's a kind of box we can consider. Okay, cylindrical is given to us, so we can consider a cylindrical. We can consider a cylindrical one. There will be some area of this, and it will be balanced with the some length of this is inside of the liquid and some is outside of the liquid. Now, to find out the value of time period, we generally displaces it a small displacement with the force analysis. So what is the additional force? We can write that. So additional force in this case, if you dip it x distance, right? So can I say that it will be equals to the extra buoyant force? Extra buoyant force will be rho, which is the density of the liquid. So in the first case, it is ρ1 times the volume increased. So x you have increased in the downward direction. That means you are dipping it more in the liquid. So x will increase. Total increase in the volume will be A into x, correct, times G. This is the volume, right? This is the volume, rho, this is the volume, and this is the mass, total mass, this is the volume, and into G. So M into G, that will be the force, correct? That will be the buoyant force. This is the very first case, right? So if you write down the time period in this case, it will be 2 pi under root m by k. Now this is k for SHM. If you look at this part, this will be F is equals to ρ1 A G times x. So the value of k of SHM is rho mass of this, complete mass of this, right, and times divided by k of SHM. So k of SHM is ρ1 A G, correct? This is the time period in the first case. Now in the second case, can I say that the value of time period is 2t, but the formula will be same. Now they are changing the density, and if we displace it again x, this will be the same. So can I directly write down the value 2 pi under root m by rho 2 AG. Right. Now I need to find out the ratio of rho 2 by rho 1, and be careful with this part because they have given 4 and they have given 1 by 4 also. Right. So when you solve these two equations, this one and this one, you will be getting 1 by 4 as the answer because they are asking for rho 2 by rho 1. Next, one main scale division of a vernier scale is, so 1 MSD is given to you. 1 MSD is 1 mm. And they are saying that we have 10 divisions on the vernier scale. Total 10 divisions are there. When both the jaws touch each other, the vernier scale shift to the left of 0. That means there is a negative 0 error. So in this case, they have given that fourth division of the vernier scale is coinciding with the main scale. So if we go with the actual formula, this comes out to be 1.06, right? But if we use this information and if we just blindly write the values, like, okay, the reading in the normal case when this is closed, so in that case reading will be, for the 0 error, if I'm writing, that will be 4 into least count. Now what is the least count of this? So we will consider that 10 MSD will be equals to, 9 MSD. 9 MSD will be equals to 10 VSD. Actually, this information is not given to us that 9 MSD is equals to 10 VSD, but this is the default case, right? So the value of 1 VSD will be 0.9, right? 0.9 mm. And least count of the vernier caliper is 1 MSD minus 1 VSD, which is equals to 0.1 mm. And if you write that, so 4 into 0.1, this comes out to be 0.4 mm. The reading of the vernier caliper with this error is 1 centimeter, and you need to tell, or you need to write down the value of actual length of the wire. So actual length will be observed plus the negative 0 error we have. What is the negative 0 error? We have 0.4 mm. Correct. And this is 1 centimeter. So I can write this as 0.04 centimeters, and this comes out to be 1.04 centimeter. In that situation, it is the fourth option. Now, in this case, you have a solid sphere A. You have a solid sphere A of radius r, mass m. So this is mass m, radius r. Then you have solid sphere B, right, having mass small m, radius small r. So this is small m and small r. Now you need to write down the value of IA and IB. These are the two situations given to you. So if you write IA, so can I say that this is the natural axis of this sphere? So I'll write that 2 by 5 capital R, capital M square, right, like this, m into r square. Then plus the moment of inertia of this about its natural axis, and that will be 2 by 5 small m r square, correct? Then we need to add, or we need to apply this distance also. This will be capital R plus small r. So we need to apply the parallel axis theorem for this small sphere, and then only we can calculate the moment of inertia of this small sphere about this line, right? So this will be plus, this will be plus capital M plus small m into, this will be the moment of inertia of this for this one. So m into the distance. Distance is capital R plus small r square. Similarly, if I write the value of IB, so for IB, this is the natural axis for the smaller sphere. So this will be 2 by 5 small m r square. But for the bigger sphere, we need to write down first about its natural axis, and then we need to apply the parallel axis theorem. So this will be 2 by 5 capital M R square plus this will be M, this distance will be capital R plus small r. So this will be M into R plus R square, right? When you take the difference of these two values, right, these value and these values are same. So this will be IA minus IB, so M minus M, second option. M minus M, R plus R to the power 2. Next, consider a spring mass simple harmonic oscillator in one dimension, and the value of mass of the particle is M, spring constant is K. At a given instant, the extension of the spring is x meters. At some point, this is x meters, natural length was L, let's suppose, and the speed of the particle is v, okay? This much information is given to us. Then, on the xv plane, if the graph of v as a function of x is a circle, then the correct option. So you might be aware of this formula, that v square by omega a square plus x square by a square is equals to 1. Or you must be aware of this formula, omega into a square minus x square. Both are same in different formats. This is used to plot the graph between v and x. And to learn this part, this is v by v max square plus x square by x max square is equals to 1. Now they are saying that we want a circle. We want it to be a circle. And to make this as circle, we need this and this to be same, which means that omega a square should be equals to a square, which gives us omega as 1. And you know one formula, that k is equals to m omega square. Value of omega is 1, so value of k will be m. Second option. Next, 29th. So lens combination as shown in the figure, okay, consists of two lenses, L1 and L2. The focal length of the first lens is plus 10 and this is minus 10 centimeters. The position of the image formed is, so this is 30 centimeters. You know this formula of magnification, V by U is equals to F by F minus, this will be plus for the case of lens, and this is the formula for the V. Now we can use this formula, V is equals to Fu by F plus of U, to calculate the value of final image formed for this lens, right? So if we write the values, U will be minus 30 for the first lens, F is plus 10. So if I write that value, this will be 10 into minus 30 divided by plus 10 minus 30. This will be minus 300 divided by minus 20. So this comes out to be 15 centimeters. Correct. So after this point, it will be formed at 15 centimeter. This lens is placed at 3 centimeter. So this distance will be 12. Right. Now for this lens, for the second lens, this distance will be the object distance. Right. And as the light ray is coming from this side, this is the direction of light, and this is the distance of the object. So this will behave as the virtual object for the second lens. And that's why the value of U for the second part will take as plus 12 centimeter. F is minus 10 centimeters. So V value will be Fu by F plus of U. And this comes out to be F is minus 10 times 12 divided by minus 10 plus 12. Right. So this will be minus 1 by 120 divided by 2. This is minus 60. Minus 60 means that the image will be formed in front of this. Image will be formed in front of this at 60 centimeter. So 60 centimeter to the left of the concave lens. Next, an AC voltage, this is the voltage given to you, is applied to a LCR circuit, right? Series LCR circuit. That means this is the case. And this is the voltage which is applied to this, right? The values of L, C, R is given to you, and you need to find out the current amplitude in this circuit. Current amplitude you need to find out. So for that part, you need to calculate Z. And if you look at carefully, the value of XC will be equals to value of XL in this case, right? XC is 1 by omega C, XL is omega L. The value of omega is this, 2 into 10 to the power 3. Put that value, you'll get 1 by 2 into 10 to the power 3. C is 25 into 10 to the power minus 6. And similarly, if you solve this part, this comes out to be 20, correct? And this will be omega 2 into 10 to the power 3. L is 10 into 10 to the power minus 3. Again it is 20. So XL is equals to XC. And you know that formula of Z is under root of R square plus XL minus XC whole square. This is 0. Value of Z will be equals to R. And the value of I naught will be equals to V naught by Z. In this case, V naught is 220 divided by R is 100. So the value will be 2.2 amperes.
Okay, let's start with the question number 31 now. What is the question stating to us? A thin horizontal disc is rotating about a vertical axis passing through its fixed center. The word is fixed center. That means that the disc is not moving at all. So what should be the ratio of the angular momentum it is asking about this point LA is to LB. So what can LA be written as? LA can simply be written as I omega. What is LB written as? It can simply be written as I omega again. What is the ratio of these two quantities now? It comes out to be 1:1. So answer is third option. Moving on to the next question after this. There is a conducting loop of finite resistance lying on the xy plane. There is a constant magnetic field in the z direction. Area of the loop varies with the time as A equal to A naught 1 plus sine t. So we have to find out what is the power dissipated in the loop as a function of time it is asking. How to do this type of question now? So first of all, it is based on the electromagnetic induction, right? Since it's based on the electromagnetic induction, we will be finding out the EMF for this question first. So EMF can be written as dBA by dt. What does it come out? EMF will come out to be BA naught cos t. So, right? Now the power can be written as E square by R. So what is power proportional to? Power is proportional to cos square t in this question. Since it's proportional to cos square t, it means what? The graph should be of this sense. Second option. Is it clear to everyone? Yeah. Next question. A point charge Q is placed inside a cavity with a solid conducting sphere. Consider points A, B, C as shown in the figure where the magnitude of the electric fields are EA, EB and EC respectively. Points B and C are at the same distance from the center of the solid sphere. The correct option is what? Now there is a charge lying inside the cavity in this case. Since there is a charge lying inside the cavity, so the electric field inside the cavity cannot be zero. Why? Because there is a charge lying inside the conducting cavity. That means EA should not be 0 in this case. EA is not equal to 0. Similarly, EB and EC points are equidistant from this conducting sphere. That means EB should be equal to EC. So correct option is second option. Moving on to the next question. There is a charge charge insulating sphere with a radius r and fixed total charge q. There is a point charge minus q with a mass m released from rest at a distance 3r from the center of a charge sphere. When the point charge reaches the surface of the sphere, its speed will become what? What is this question based on? This question is based on loss in potential energy is equal to gain in kinetic energy, right? So we have to use this concept now. Loss in potential energy is equal to gain in kinetic energy. We can write it down. What is the loss in potential energy in this case? Loss will be what? It will be simply written as Q multiplied by KQ by R minus KQ by 3R. That should be equivalent to what? Half mv square. So V comes out to be under root QQ divided by 3 pi epsilon naught mr. So correct answer is third option for this. Moving on to the next question after this. In a Geiger-Marsden experiment, the number of scattered alpha particles is plotted as a function of scattering angle theta. Which of the following options represent the correct plot? So now in this question, the number of particles is proportional to 1 by sine 4 raised to power theta by 2, it can be written as. Right, since it is inversely proportional to a sine function, so the graph should be third option in this case again. Moving on to the next question. Right, so there are two circuits A and B each having a resistance, two resistors. One of them has a positive temperature coefficient of alpha, while the other one has a negative temperature coefficient minus alpha. So current through these circuits are denoted by IA and IB. At initial temperature, the resistance of the two resistors is R0. As the temperature is increased, the correct option that describes the variation of current in this circuit should be what? So now, first of all, in a series circuit, the current will remain constant. IA should be what? V by 2R0. Similarly, while in the second circuit, the overall resistance of the circuit will decrease. Why? Because this is connected in parallel. They are connected in parallel, so that means the equivalent resistance is small. So the equivalent resistance is small, that means IB should what? Increase in that case. So that means the correct option for this answer is IA remains constant while IB increases in this case. Moving on to the next question. So there is Stephen's constant, there is a Boltzmann constant, and there is a Wien's displacement constant given to us. We have to represent which dimension is correct in this, what is the correct relation between all these quantities. So now, what can the power be written as? Power can be written as sigma A t raised to power 4. This implies sigma can be written as what? Power over A into t raised to power 4, right? So what does it come out? Energy over time, A into t raised to power 4 it comes out to be. That is the value of sigma here. Now, similarly, what is the value of Boltzmann constant here? So, Boltzmann constant 3 by 2 kBt can simply be written as energy in this case. So, what is kB comes out to be? That's the Boltzmann constant here. So, it will come out to be E raised to E by t. What is the dimension of this quantity now? This will be ml2 t minus 2 divided by k, it can be represented as. What is the dimension we are getting for this? ml2 t minus 2 k minus 1. Right. Similarly, what is the dimension of Stephen's constant here? It can be written as ml2 t minus 2 over t a. Now a can be represented as what? A can be represented as L square into Kelvin raised to power 4. So what we are getting for this? We are getting m t minus 3 k minus 4 for this expression, right? Now, what is the expression for Wien's displacement constant? B. B can be simply written as lambda times t. What is this expression now? Lk. So if we multiply all these expressions now, what expression we will be getting for this? Sigma k minus 1 kb minus 1 into b we have to find out. What you are getting for this? Into B. So what we will be getting for this expression now? See, sigma is what? mt minus 3 k minus 4 is the expression for this. Then what is for the Boltzmann constant here? It can be written as m minus 1 L minus 2 T2 K, it can be represented as. Now similarly for Wien's displacement constant, what is it? L into K. So what expression we are getting for this? This comes out to be L minus 1 T minus 1 K minus 2. This we are getting for this. So correct answer is option number 1. Moving on to the next question after this. An electromagnetic waves traveling in the dielectric medium having a dielectric constant epsilon r equal to 9 has an electric field is given as this. So first of all, which is the incorrect option we have to choose? Which is the incorrect option in this? So speed of the electromagnetic wave in the medium is what? First of all, we have to calculate the speed in the medium. So for calculating that, V can be written as V naught divided by root under epsilon r. What is this expression now? This comes out to be 3 into 10 raised per 8 over 3. What is the answer here? 10 raised per 8 meter per second. So that means that velocity is correct in this question. So this option is correct. Then wavelength of the electromagnetic wave inside the medium is 300 meter. Now let's check this option. What is the frequency for this question? Frequency will be omega by 2 pi. Right, so what is it coming out to be? It comes out to be 10 raised per 6 here. Now, what is the wavelength here? Wavelength can be written as V over frequency here. What does it come out? 10 raised per 8 over 10 raised per 6. So we are getting 10 raised per 2 as the wavelength here. So that means this option is incorrect. Second option is incorrect. Then similarly, magnetic field is given by B naught by V. Since it is B naught by V, it should not be, this is incorrect option that they have stated in this question. So E should be written as, E naught should be written as B naught times V. That means B naught can be written as E naught by V and not as B naught by V. So this is the incorrect option again. So the correct answers for this question is 2 and 3. Moving on to the next question after this. So 1 mole of an ideal monatomic gas undergoes a cyclic process as shown in the figure. The total heat supplied to the gas is what? So now, it is a cyclic process. Since it's a cyclic process, so Q should be equal to what? W in this question. Right, Q is equal to W. So now what is the work done in this complete cyclic process? W can be written as area of this rectangle basically. What is the area of this rectangle now? It should be 200 multiplied by 3, that comes out to be 600 joules. So that means heat supplied is what? 600 joules in this question. So answer should be third option. Moving on to the next question after this. So there is an electron revolving in an excited state of hydrogen atom with a velocity this much. The radius of the orbit is what? So which relation we have to use in this question? For solving this question, we have to relate the centripetal force with the electrostatic force in this question, right? So what is the centripetal force? mv square by r. That should be equal to k times e square by r square. We can write it down. Now, what is the radius in that case? Radius will be simply written as k e square by mv square, it can be written as. So now the correct answer for this question is fourth option. Moving on to the next question after this. A car travels on a circular racetrack which is banked at an angle theta. If the car travels at a speed of 10 meter per second, the wear tear of the tires is minimum. For minimum wear and tear of the tires, that means that tan theta can be written as what? V square by GR, because the minimum friction is acting in this question. Since the friction is minimum in this question, that means V square should be equal to tan theta should be equal to V square by GR for this question, right? Then, so tan theta comes out to be what? V square. V square is what? 100. 100 over 10 into 5, 50. So this comes out to be 1 by 5. So theta is what? tan inverse 1 by 5 it can be written as. So correct answer for this question is option number 1. Moving on to the next question after that. So there are 3 diodes given in the question. If the width of the depletion region of D1, D2, D3 are W1, W2, W3, then the correct option is what? So now, this diode is connected in a reverse bias condition. This diode is an open circuit and this diode is a forward bias condition, right? When it is in the reverse bias condition, that means that the depletion region will be maximum in that case. So W3 should be maximum. Which are the maximum options we are getting for this? Third option and only the third option we are getting. Now let's look at the other options for this also. Since diode D2 is connected in the open circuit, so the depletion region should be a bit less than the W3, but it will be more than the W1. Why? Because it is in the forward bias condition. So the correct option for this question is third option. Moving on to the other question. Following table represents the part of electromagnetic spectrum and their corresponding major applications. Microwave. What is microwave used for? Microwave is used for warming the food. So P is matching with the 2 option and UV rays are matching with the purification of water. We generally use UV rays in the RO of our homes, right? So what should be the correct option for this? Let's look at the options now. Q is matching with 2 in this. No, it is not matching with 2. Q is matching with 1. So which option should that be? That should be the third option in this question, because there is only one option in which UV rays is getting matched with the option, that is purification of water. So answer should be third option in this case. Moving on to the next question after that. There is a bob of mass m hanging vertically from the ceiling with a massless string of length 10 meter. Point mass A of mass traveling horizontally with a speed of 10 meter per second hits bob B elastically. Since it's an elastic collision with the bob, basically, now what should happen in that case? The entire velocity of A will get transferred to B here. Since the entire energy is transferred to B particle here, what should be the velocity of B in that case? It should be 10 meter per second. Now we have to calculate the height rise. So what is the formula for that? H can be simply written as VB square by 2G by mg. VB square by mg it can be written as VB square by mg. So what answer we are getting for this? This should be 100 divided by mass of the particle is what? VB comes out to be 10 meter per second in this question. Then VB is 10 meter per second in this question. Now listen one thing. So VB square can be written as simply as VB square by 2 can be written as GH in that question, right? So now what should be the height of the particle now? VB square by 2G it can be written as. So what answer we are getting for this? 5 meter as the answer. So answer is third option. Moving on to the last question. An ideal gas is made up of a polyatomic molecule. Each of the molecule has 3 translational. What are the translational degrees of freedom here? TF can be written as 3 in this question. TR can be written as 3 in this question, and there are T vibrations as F. Now, see, what is Cp by Cv written as? Cp by Cv can simply be written as 1 plus 2 by F. Right. What is Cp by Cv for this question? It comes out to be 8 by 7. That should be 1 plus 2 over 6 plus F. Right. So answer comes out to be 1 by 7 equal to 2 by 6 plus F. Now, what is this relation now? F comes out to be 8 in that case. Now, there are 2 vibrational degree of freedom basically for a polyatomic molecule. That means F dash should be written, F can be written as 2F dash in that case. So what is F dash in this question we are getting? F dash is equal to 4. This implies that total vibrational degrees of freedom are 4. Okay, vibrational degrees of freedom are 4 in this case. How? Basically, in a polyatomic molecule, there are the number of kinetic energy, the number of kinetic energy degrees of freedom are same as the number of potential energy degrees of freedom. This implies that the total number of degrees of freedom, if they are coming out to be 8 in this question, that means the degrees of freedom will be F number of vibrational modes will be what? 4 in this question. So answer is first option. Thank you.